This is usually a trickier one because there's some substitution happening, so let's go through two more examples. Example 3. We want to express log base 2 of 32 to the power of 6 as a product, then simplify if possible. So again, this is twofold. The first is we want to use that product or that power property. So we want to rewrite this as a product of the exponent times the logarithm. So here, my exponent is 6. I'm going to kick the 6 to the front of the logarithm to give me 6 times log base 2 of 32. Now I need to start simplifying. So to kind of do a little bit of color coding, what I've done so far is I've answered the part of the question where it says to write this as a product. I've done that piece. Now I need to work on simplifying. So the first thing I'm going to do is I need to figure out what is log base 2 of 32 equal. In order to answer that question, I have to think that base of 2 to what power is going to give me that number 32? And that would be 5. Now I have to do 6 times 5, which is 30. So this piece, where I've boxed up the number 30, is answering this part of the question where it says to simplify. So writing it as a product is to take that original exponent and multiplying it in front of the logarithm. Simplifying means we need to evaluate the logarithm and multiply it by that number in front. So let's do this one more time. Express log base 8 of 8 to the power of 20 as a product. We take the exponent 20 and we kick it to the front of the logarithm. Now we do a little bit of simplifying. Log base 8 of 8 is 1, so I have 20 times 1, which is 20. So when you're doing these problems, you have to show all three of these pieces, right? You have to show your work and your thought process. So you first have to show me what I had boxed up in green there, where it's 6 times the log base 2 of 32. That's part of the answer. Part of your work then is the 6 times 5, and then you have your answer, which is 30. Oops. So that is the power property. One of the very last things we're going to talk about is the change of base. The reason why we have this change of base property is because sometimes we can't evaluate logarithms based upon how they're written because the answer is a decimal or a fraction or it's irrational or something of that nature. So that's where the change of base property comes into play. So if I have log base 2 of 16, what I can do is I can use the change of base property and I can change it to any base I want to. Now, you can change it to a base where sometimes it works out that you can do this by hand, but not always. Sometimes you're going to have to use the calculator for your change of base, and you're going to have to write down some decimal answers. So I'm going to show you how to change it to a base of 10, and then what that looks like in terms of typing it into the calculator. So change of base property. What it is I have log base 2 of 16. I know that this can technically be evaluated and not have to change of base, but I want to use this as an example to show you how the change of base works. I'm going to change it to a base of 10 because base 10 logarithms we can type into the calculator. What you do is I'm going to end up creating a fraction. So I'm going to have a log base 10 of the original number that was being plugged into the logarithm, which is 16, divided by log base 10 of the original base, which is 2. So I keep the same base because I changed the base, right? So they're both log base 10 in that fraction I created. The original number being plugged into the original problem is in the numerator. The original base is what's being plugged into the denominator. What I do now for plugging this into the calculator, if I can find it, here we go. And if I make this a little bit bigger for you, there we go. So what we're going to do is we'll turn the calculator on. Let's see here, there we go. Clear that out. you'll notice that there's a logarithm button right here. It's just to the right next to the 7. You're going to hit that. And notice that there's no base typed in. That's because base 10 is the common logarithm, so you're not going to see a base. So the first thing we have is log base 10 of 16. So then I'm going to type in 16. This is much more challenging to do this backwards, but we're making it work. All right, divided by, and then I have log base 10 of 2, like so. One important piece is to make sure that here, next to the 16, you close the parentheses before you hit the division bar and start typing in the second logarithm. And then we hit enter. Nope, I didn't hit enter. Enter, and we get 4. So we know our answer to this is 4. Like so. So let's go through 2 more problems like this. So example 4, which you can't see anymore because my face is much too big. Example 4 says log base 32 of 8. So what we are going to do is we're going to use change of base. I'm going to use base of 10. So I'm going to take log of 8, and I don't have to write in the base because it's a base of 10, so I don't need to write the number there, but you can if you would like to. So I'm going to take log of 8, because 8 is the original number that was being plugged into the problem, divided by log of the original base, which is 32. Again, typing that in means I'm going to have, let's see here, log of 8. And then I got to close my parentheses. This is difficult. Let's see. There we go. Divided by log of 32. Nope, that's not it. There we go. And I hit enter, and I get 0.6. So let's do that one more time with example 5. Using change of base, I'm going to have log of 27 divided by log of 9. Typing that into the calculator, and I get 1.5. So we've talked about all the different properties of simplifying logarithms, but we're going to talk about inverse properties and how it can make things easier to simplify, right? Because remember, a logarithm and an exponential function are inverses. So when they're composed inside one another, they all cancel, their operations cancel one another out. So this first one says, if I have log base b of b to the power of x, that logarithm and that base cancel one another out, leaving us with just the x. Similarly, if that logarithm is an exponent with the same base as the exponential function, they cancel one another out, leaving me with just x. So let me show you an example of each of these. So I'm going to label this as 1. So an example of this is if I have log base 99 of 99 to the power of 4, that is going to equal just 4, because this part in a way just kind of cancels one another out. They undo one another's operations. Very similar to how if I have 5 squared but I square root that, the power of 2 and the square root sign cancel each other out, right? This works in the exact same way. The logarithm and the exponential equation having the same base undoes one another's operations, leaving us with just the exponent. Going through and showing you an example of that second property, if I have 599 to the power of log base 599 of 23, I'm making these numbers up as I go. Notice how the logarithm, which is an exponent, has the same base of the exponential equation, so those pieces undo one another's operations, just leaving me with then the number 23. Right? Okay, so that wraps up 4.4, which is looking at properties of logarithms. If you have any questions, please let myself or Mr. Brasser know. Have a great day.